Okay, today we're going to continue our discussion about the disc and washer method. But today we're going to rotate around axes that are vertical. So yesterday we rotated around the x-axis to begin with, and then we rotated around different axes that were still horizontal. Y equals 2, y equals 4, y equals -1, whatever it was. Okay? Today we're going to focus on rotating around vertical lines. So we're going to start with the y-axis, and then we'll look at axes that are not the y-axis. Okay? So just like yesterday, we're going to rotate rectangles around an axis, but this time we're going to rotate horizontal rectangles around a vertical line to get our discs or washers. Okay, so I want you to look at that green rectangle and imagine it rotating it around, okay? And I want you to imagine that washer.
Have another animation.
Does it look like that? Yeah. I don't know if I have the animation this time for these twisting around. You like that?
I did.
Okay, so same thing. We need to figure out what the big radius is and the small radius to subtract it out. We still have those really thin cylinders, right? So pi r squared h is how we find the volume of a cylinder. But this time, since we have horizontal rectangles, their thickness or their height is dy. Okay, Joe?
So it's just the same thing, but when you revolve it around the y-axis, it's the same.
Yes. Okay. But now we have to go in terms of y. Okay. So when we rotate about the y-axis with disc and washers, this is what we're going to use. It's the same thing from yesterday, pi r squared minus r squared h. However, now, since we're using horizontal rectangles, their thickness is dy, and we must do the integration in terms of y. Yes.
So they're capital letters, like and doesn't capital letters mean antiderivatives, or is that just?
So I called these capital letters just so that they wouldn't be the same as what you had yesterday in your notes. Like
Okay.
f of x and f of y are two different things.
Yeah.
So in this case, I am not referring to an antiderivative. Okay. No, thank you for asking about that. They're just not going to be they're not going to look the same if I have a function written as x versus y. Okay. But that is something that we'll need to talk about. Okay. Very similar to when we did area. If we're going to rotate about the y-axis or any other vertical line, we're going to need our equations to be functions of y. So x equals something in terms of y. So if it's not, we're going to have to make it that way. Okay. So let's do some examples. Okay. Go ahead and write this down. It is important, especially at this point, to make a note of what axis we are rotating about. I know some of you are probably trying to write down as few words as possible, right? I'm with you there. So you're writing down y equals 2x squared, y equals 0, x equals 2. But make sure you say about the y-axis so you know where you're rotating it about. Okay? You can even make like a little circle arrow instead of writing about. Okay. So the first thing we need is a graph. Y equals 2x squared, that's just a parabola that's stretched out a little bit. And then y equals 0 is the x-axis, and y equals 2 would give us that shape right there. Okay, so we're taking that, can't really call it a triangle, but triangle-ish shape, and we're going to rotate it about the y-axis, okay? So the only way we know how to do that is using Disker washers. So we would have to put in a horizontal rectangle with thickness dy, so that when we rotate it about the y-axis, we get that washer effect, okay? I can't stress how important it is for you to draw that rectangle and imagine the shape, because here next week I'm going to teach you a second way of doing these volumes, and you need to be able to picture what kind of shape you're rotating around. Okay? All right, if you want the visual, this is what we'd be getting. Okay, kind of like a. Almost like a glass, right? Like you've seen glasses where like it kind of just dips in inside. Right, right. And it has like a thicker base to support the glass so it doesn't knock over. Okay? That's kind of what it looks like to me. Regardless, we need to find this volume. Okay? So we are still in the mindset of pi r squared minus r squared h, okay? And since our thickness is dy, we are integrating in terms of y, that is the height of our cylinder, okay? So when we talk about the radius, which piece of the rectangle in my picture is furthest away from our axis of rotation? Okay, so this is my outer radius, it's the furthest away. And so axis of rotation is 0. We don't have to really worry about that number. And so we're going to put 2 in for our outer radius. And then the left side of the triangle, the left side of the rectangle is closest to our axis of rotation. That would be 2x squared, right? No, we can't put in 2x squared. Okay? So y over 2 is x squared. So yeah. Technically it would be plus or minus square root of y over 2. But Trevor, which one is it going to be? The positive one, because we're on the positive side. Okay? Thank you for bringing up the plus or minus, because those will be important in other problems. Okay, but we really only have to worry about the positive one, since that's the side that we're working with. Okay? All right, now I need to ask you about the limits of integration. I need to ask you about the limits of integration. Think about it for a moment. I know you know it. I just never want to think about it. First of all, are our limits of integration 2? Or 0 to 2? Okay, those are the x ones. We need to figure out what the y values are. Okay? So our limits of integration, Michael, what would they be? 0 to 8. Do you agree? Okay. This coordinate right here is 2, 8. So we're going from 0 to 8. Okay. Now, is this one that you could do by hand? This one wouldn't be terrible, right? Because you would have pi integral from 0 to 8 of 4 minus y squared over 4. It wouldn't be the prettiest integral in the world, but you could do it by hand, technically, and be fine. We're not gonna go through it, but you could. Okay. You guys have a question? No? Okay. All right. Yes.
Why is it wise?
Yeah, wouldn't it just be 5 over 2 into 5 over 2?
Yes, it would be. I just totally ignored that square root behind. Better? Okay? Sorry if you're watching this from home. Y over 2, because the square and the square would cancel. I just totally disregarded the square root. Okay? Now that makes it even easier to do the integral. When we're probably not going to go through it by hand. I think Will is typing it in his calculator right now. So you let me know. What you get.
So if you're trying to find the middle integration of the a, would you set your radical y with 2 equal to 2? Is that how you would find it?
Yes. Yes. Okay. So Catherine asked, if you didn't know your limits of integration, would you set radical y over 2 equal to 2? Okay. Same thing like what we did before. Oh, I just erased it on the board. We had y equals and y equals. We set them equal to each other. In this case, you're going to want x equals and x equals, set them equal to each other. Okay? Joe, did you have a question, or did I imagine your hand?
I found the
Oh, okay, what is it?
pi.
16 pi?
16 pi.
16 pi.
Where's the...
That's a nice number.
Oh, I forgot.
Did you have 16?
Yeah.
Okay.
Brother was like a
Okay. Okay. And just a reminder from yesterday, find the integral without the pi, then multiply the pi at the end. Okay? All right.
Let's do CJ for 2 seconds.
Sure. Now for 10 seconds.
This will only take 2 at a time.
Write down what you need to. Their composition this weekend. Is it color guard?
Color group question and Williams on the competition.
And so to show band and show fire also.
Here?
Not here.
But somewhere else.
Yeah.
Yeah. I knew show choir.
Yeah.
It was just crazy
But
right
it's
now.
weird because half the show band is in that, so they're having to go back and forth.
That's such a mess.
It is.
It is a mess.
So it's winds, percussion, and guard all this weekend.
I'm in 2 of those. There's actually percussion in the winds group as well.
Okay, thank you. I was like, I know you're not in guard.
Yes, keep that.
Well, because you don't have the little sweatshirt that they all have. Right? Yeah. Okay, do you have your picture drawn? What is this shape going to look like?
It's going to be like there's 2 curves.
It's going to look like a, kind of like an M&M, if you look like an M&M from the side.
The wrapper.
In the lips.
Right? If an M&M is laying on its side, wouldn't it look like that?
Yeah.
Yeah? Okay.
Looks like a football.
That would be another good description of it. Okay? So here is where it's really going to be important for you to label. They look like the same shape, right? Like the boundaries look the same. There's some symmetry going on. So this right here is y equals radical x, and this right here is y equals x squared. Okay? Now, if we are going to rotate this about the y-axis, then we have to make rectangles that are horizontal so that we have thickness dy, and those are going to create washers. Okay? Yeah, it would be nice to go in terms of x, but that's not going to create washers when we rotate them around, because they're going to be shells, and we'll learn about that next week. Okay, now, if we're going to be using dy, we don't want y equals radical x and y equals x squared, do we? No. Y equals radical x, we would instead rewrite as what? X equals y squared, okay? And y equals x squared, we would write as, oh, what are we going to write this one as? Okay. X equals radical y, and I'm going to keep it as just the positive because the negative radical y would be over here. All right, so we're going to twist this around the y-axis. Okay, since the y-axis is our axis of rotation, we're just looking at where is the right side of the rectangle and the left side of the rectangle, how far are they away from the axis of rotation, in this case the y-axis. So which one is further away?
Radical y.
Okay, radical y over here on the right side is the furthest away. So we have pi integral, we'll worry about limits later, r squared minus r squared h. So furthest away, our big radius is going to be radical y, and our small radius would then be y squared. Okay, our limits of integration, this one is pretty nice. Marcus, what would our limits of integration be?
1 and 0.
Okay, from 0 to 1, that's where those two intersect. Okay, this is a very rare case that both x and y would have the same limits of integration. Okay, as I mentioned yesterday, my biggest concern is not you performing the integration. My biggest concern is you setting up the problem. Okay, so we're going to set one more up, and then I'm going to give you some work time, because I think you deserve that after this week.
Thank you.
Yeah. You're welcome.
You weren't here yesterday.
Hey, I was still on the ground.
No, you weren't.
Math tonight.
Were you the three problems? Okay, draw this picture. Oh, hey. You already have the picture drawn, don't you? Okay, so write down the information that you need to, and then we'll redraw the picture, but we already know what this looks like.
Oh, sorry, got it.
You were looking at the y equals radical x, right? Yeah, I went ahead and changed them like we did on our last slide, okay? And we're rotating around the line x equals 10. Okay? So if we're going to rotate around a vertical line, we have to have horizontal rectangles with thickness dy. Okay, so now we are rotating around an axis that is not the y-axis. So we're going to have to think about the distance of each side of the rectangle from our axis of rotation. So go ahead and talk to your neighbor. Describe the outer radius and describe the inner radius. Don't write them down, just describe. Go.
Like the one from the
Wait, what did you say?
Farther away. So I guess the inner one, I guess it's supposed to be.
What?
It's like,
They're going down the road.
All right, Catherine's keeping me in check over here. I did draw my arrow. All right, so as we rotate this around x equals 10, the side of the rectangle that is furthest away from our rotation would be what?
Y squared.
Y squared, okay? So how are we going to write the outer radius?
Oh. It would be 10 minus y squared.
Well, poses a question. Would it be 10 minus y squared? It would be, because 10 is to the right of it, it has to come first, minus left y squared. Okay, so that leaves radical y as the inner radius, so 10 minus radical y would be your inner radius. And of course, r, 0 to 1. Okay. If your axis of rotation were to be on the left side of your region, then it would be the opposite, right? You would have to say curve minus line, curve minus line, and you saw that yesterday, okay? Do you think I'd make you do that one by hand? I hope not. No, I'm not making you do this one by hand. Okay? All right, so we have, look at that, 15 minutes. 15 minutes of class time. I bet you can get half your homework done, and then you have the rest of the homework to do at home. So that'll free up 15 minutes. That's worth one game of Fortnite, right? Yeah.
even though Fortnite sucks. Fortnite's overrated. But it wasn't